Good evening, everyone. Sorry for the delay. So, yeah, welcome to section 6 of the Data Science Youth Drive program. I'm excited to have you all once again in class. So today we're going to be continuing straight up from where we stopped in the last class. So we would actually not waste much time with other stuff because we need to finish up with Python programming generally today. Because from next week, we're going to be moving on straight to packages, right? So today we're going to be wrapping up with what we have for Python programming. So we've actually come a long way. This is the 6th class so far. So if you've been keeping up with us from start, I'm very sure and confident that you would have gotten to a level of proficiency with Python. You should be able to do some things. For those that are entirely new to Python, you should be able to comfortably work or write some Python code at this point. So I believe that is true for most of us here. So yeah, we are making a lot of progress. We still have a long way to go. So basically, the program, I didn't say this initially, but the data science program is the data science course outline for this program is kind of segmented or separated into 3 parts. All right. So this is not an official pressure, right? It's just to help you categorize them in your head and categorize the sessions and the classes we'll be having. So the first part is what we've been doing so far is introduction to Python, teaching you about Python and how to use Python generally, and just to bring you to a point of proficiency using Python. All right, that's the first part. Then the second part is then data analysis, right? So we're going to be moving on to using Python packages for data analysis and data manipulation. All right, so we're going to look at some libraries. We're going to look at NumPy, Pandas, Matplotlib, and yeah, so those are the 3 major libraries we're going to be looking at. So that is the second part of this course or this program. So the third part is going to be machine learning. All right, so we're going to look at Python programming first, then move on to looking at data analysis. We're going to wrap up with machine learning, right? So for the past 3 weeks, we've looked at Python. All right, so we'll be wrapping up with this segment with today's class. So starting from next class, we're going to be moving on to the second part of this program, which is using Python for data analysis and data visualization. So after that segment or that part of the course, we are now going to proceed to machine learning. All right, so we will basically be climbing up a ladder, and the higher we go, the more sophisticated or complex the classes become. All right, and I'm not saying this to scare you or anything, but if you've been following us from start, you're going to actually have it easy to understand. It's going to be very easy for you to understand. So that's why I usually advise us that we should keep up with everything we are doing, both the classes, the assignments, keeping up with questions that are being asked in class and materials and all of that. So when we get to those points that might look advanced, you will not have an issue understanding or grasping what we're doing there, right? I'll try as much as I can to break down this concept, right? This seemingly hard concept into bits and pieces for you to digest. So as long as you're doing what you're supposed to do, you won't have a problem with this program, definitely, right? So I told you at the inception of our class that we have a lot of testimonies from previous students that had no prior knowledge to data science, that had no prior knowledge in data science, right? After the program, they became very comfortable with data science, Python, and machine learning, right? So it can be the same for you, all right? If you came in here blank, you will definitely not leave the same way. So that's just what just what I'm going to tell you about that. So moving on, just quickly, we've selected our class reps, right? So I think that we've done justice to that already. So we're going be working with. I'm going to be working with them to ensure that our classes go as smooth as possible. So Gideon is going to be our class rep moving forward, and Nigeria is going to be the assistant. So basically, the both of them will be working hand in hand to ensure that everything works very well, and the classes are going very well, and every issue that you might be facing um, gets to the appropriate person, right? So that would definitely be me. So we just want to ensure that everything is easy for everybody, because I usually get overwhelmed with text, right? You might feel I'm not replying you, but that's not the case. I have a lot of DMs which lose track of how many is coming in. So it's going to help us make things smoother and help me address pertinent issues, all right, that you might be facing. So the reason why we had the different subgroups in the group was so as to address questions. We have the Q&A, and I think we still don't understand the essence of this group chat. I don't want people coming into my DM and asking me questions that you can easily just ask in the group. If you come to my DM and I don't reply, your problem will still be left hanging, right? But if you ask the question in the group chat and tag me, you might even get the solution or a response even before I see the message, because some of your other colleagues might have faced similar issue and have solved it, so they can just easily give you the solution to that problem. Like, you can actually see that happening, right? Because I can see some of us helping each other in the group. And before you come to my DM, make sure it's a very personal issue that you cannot share in the group. If I don't reply your personal DM, you know that yes, I'm not to be blamed, because we've made the appropriate we've provided appropriate channels for you to ask these questions. So now that we have our class reps, the same thing applies. Don't come straight to me. Go through the class rep, and if it's something that will require you to come straight to me, then I'll take the class rep to inform or to tell you to chat me up directly. All right. So if I get any other DMs that are not very personal, right, I might not reply to the DM, just to ensure that I just to help me generally, because there are a lot of things I'm trying to join this program. So that's going to be it for that. Congratulations once again to the class rep and assistant. So I believe you both will do well and lead this class very in the right direction. So let's go straight to what we have for today. So I'm going to be sharing my screen. All right. So let's. So where did we stop in the last class? Can someone just remind us, like, where did we stop in the last class? So let me just quickly talk about the week 2 assignment. The week 2 assignment has not been graded yet. So if you've not seen any grade, don't come to me. It has not been graded. If it has been graded, you will see some grades there, and then you can now like raise it as an issue that you've not seen your grade, right? So everybody has the same score at this point. So those are coming to ask for week 2 grade, please just know that it has not been graded yet. So last week we stopped at yesterday we stopped at while loops. All right, so we looked at quite a lot. We looked at string formatting, we looked at operations, we looked at for loops and iteration. For those that missed the class, the recording is already made available. So if you check the materials and resource group, you're going to see it there. All right. No, you can't submit the week 2 assignment again. The deadline for that has passed, right? There's a reason for a deadline. Once the deadline is passed, please, nobody should come and asking me if they can submit. Just focus on the next assignment. There are a lot of assignments to work with or to grade. So I have a lot already. So if you miss the deadline, that's on you, not me. So you have to focus on the next assignment and ensure that you don't miss that deadline. All right. So that's just it about that. So let's move straight to the next thing here. We're going to be looking at loop control statement, because this was where we stopped yesterday. We didn't finish up with the condition iteration, loops and iteration. So we'll quickly look at how we can use some certain loop control statements in our for loop and while loop. All right. So for loop control statement, we have 3 of them. Right. We have break statement, we have continue statement, and we also have else statement. So let's quickly look at how we use these different statements in our for loop. So it's actually pretty straightforward. But I'm going to drive home going to help us understand this better by citing some examples. All right, so let's wait for this to come up. Please, can everyone see my screen? Is the screen not showing? Oh, okay. I'm here to share the screen. All right, so I believe you should be able to see the screen now. All right. So today we are going to look at loop control statement. Let's see. Loop control statement. So loop control statement, they are basically statements that you can use to control how your for loop should behave, all right, or your while loop, any kind of loop you are using, any type of loop you are using. So we have 3 of them, as I've said. We have break, we have break statement, we have continue statement, and we have else statement. All right, so we're going to look at how we can apply these 3 different statements in for loop. So as you can remember, when we want to write the for loop, we start by using the for keyword, for. So let's just use the range function to like create a loop or a sequence. Let's say for I in range, let's say 5, or let's say 10, print I. So remember, this is our normal for loop that we are familiar with. So what this for loop here will do is just to print each of the elements in this sequence that we have created using range. All right. So let's say now we actually want to go over a particular sequence, and we want to stop when it gets to, if a condition is met. All right. Let's say you want to go through the sequence, a list sequence of from 1 to 10, and then you want to stop that sequence or the loop when the loop gets to the value or the element 5 or 6 or whatever element it is that you decide. We can come here. We can come here and say if I is equals to 5, then print breaking the loop, and then I'll come here and write break. All right, so you can see how we are using the break statement now. So the break statement always go hand in hand with an if statement, a condition. All right, so the condition here is that as we are going over this sequence, this range sequence of 0 to 9, when it gets to the value 5, when this variable here gets to 5, let me zoom in the screen a little bit. When it gets to 5, we are now going to stop the loop entirely and we're going to break it. So let's come here and print I. So if you run this now, you will see that we printed the first value, which is 0. Let me make this 1 to 10. So to start from 1. So this is going to be the output, right? It will print out the first value because we are printing I. So this if statement would not work until this condition is met. Remember what I said about if statement? As long as this condition is false, the if statement would not work. So once this loop starts, this if statement will be ignored until the condition is met. So it will be, let's just look at it as this if statement being absent. So for I in range 1 and 10, print I. So it would start from the first sequence, which is 1, to print 1, then go to the next element, 2, print 2, go to the next element, as element is I, print I. So when it gets to 5, then this particular statement, if statement here, is going to, at each iteration, we are checking this condition, right? So for the previous values, the condition is always false because I is always equals to 1, 2, 3, and 4. But when I now becomes 5, this condition will now be met, all right? It will now be met, and then it is now going to execute this particular code here, all right? So if I is equal to 5, then print breaking the loop, and then this break statement here would now break the loop, and then the loop is going to stop. So it's just like the loop execution. So that's what break statement does. All right, that is what break statement does. So someone is asking, why is 5 not captured alongside? It's because this condition is met because I is equals to 5. So we are breaking it. So once we break it, this print I will not be executed again because we've broken the loop. We've stopped the loop. Do you understand? If we make this condition to be 6, 5 will be captured, but 6 will not be captured. You can see it here. 1 will be printed, 2 will be printed, 3 will be printed, 4, 5. But when it gets to 6, it's going to now execute this if statement, and then the loop will be broken, and this particular statement or this code will not be executed, all right? So that's what the break statement does. So it kind of breaks a loop based on a condition that you're given. So let's say you are looking for, let me just use another example here. Let's just create a list of fruit, list. And let me create names list. Names lists. So it's going to be, we're going to have Job. We're going to have Cletus. We're going to have Yusuf. We're going to have Treasure. We're going to have Sylvia. Silver. Okay. So we're going to have this these different names, and then I want to use the break statement here. But what I want to achieve is that I want to break the loop when the loop gets to, let's say, treasure. All right. So when the loop gets to treasure, we're going to break it, right? So it's just like this particular thing is this particular control flow can be used in searching something or searching tree list. So I can have something like this. For name in names, if name is equals to Yusuf, then print Yusuf has been found. All right, and then break. So I can just come here and say print name. Okay, so we're going to just run this, and you see that we have the first name in the list, Job. The second one, Cletus. So when it gets to the third one, which is Yusuf, and we gave this condition, if name is equal to Yusuf, then you break this loop and you just declare that, oh, Yusuf has been found. We don't need to proceed with the loop, because what we are trying to do is we are trying to search for Yusuf in that particular list. So this is an example of using our break statement. So it's like putting a stop on our loop. So it's like a way to control the loop. So that's why we call it control. We call them control. Where is that? Loop control statement. All right. So it's a way to control how our loop is being executed. All right. So in this case, we say that break exits the loop and skips the execution of any remaining. If it gets or meets a certain condition, it exits the loop and then skip the remaining execution. Whether you still have like 1,000 execution or 1,000 loops, right? Loop remaining, it will stop as long as that condition is met. All right. So let's look at how we can use it. We've looked at while loop, right? So for loop. Let's look at how we can use it in while loop. Let's say we'll come here and pass in a variable. Let's say number is equals to 0. I can say y 0 or y num is less than 10. Let me come here and spell y away. So y num is net. If num is equal to 5, then print breaking while loop. All right. So I'm just going to come here and close it and then type break. So I can just say num plus equals to 1, and I can print num. All right. So if I run this, you see that it's almost the same thing basically. Like we are using a while loop to check if we are performing an action basically, given this condition. As long as num is less than 10, all right, we are going to number. But then you want to introduce a control flow inside that. While the particular condition is still running, we can actually introduce something else, like saying if number is equal to 5, then print breaking loop. All right. And then we're going to break the loop, and then the remaining executions will not, the remaining iteration would not be executed. So this is the same thing as our for loop. You just have to know how we can apply it for while loop as well. So I think this is very straightforward. This is how we use break statements for controlling our loops, our loops, whether it is for loop or whether it is while loop. All right. I hope that is very clear. Are we still following, and can we all still see the screen very well? Okay. So One thing about Python is that you can basically practice and try a lot of things, right? But for you to use a particular logic, you need, or a particular concept, but you need to follow through with it with a logic. And you need to have a logic that you want to implement first, anyhow, right? So you have to programming basically is solving a problem with code, right? So that's what programming is. So you need to understand the problem you want to solve and then translate it into code. So the logic has to make sense. So all these things I'm teaching you now, there are different ways you can apply them. So I'm basically giving you building materials. I'm giving you cement, and all of those things, shovel, and everything you need to build a house, right? So it's left for you to know how to structure it, whether you want to build a two-story, you want to build a duplex, or you want to build this or that, right? So I won't tell you exactly how to build it. I'm just giving you the material. So all these things, loop, control flow, if statement, and all of that, they are just like building materials. Like, depending on the problem that you want to solve, you now know which one to apply to which and how to arrange them. All right. So that's what makes you a programmer. You are not supposed to be told every single thing. You're not supposed to be told that, okay, this is how you do this thing, like giving rules and rules and rules and all of that. So we give you the concept, we give you all of that, we give you examples as well to help you understand it, and then you apply it depending on the problem you're trying to solve. All right. So I just wanted us to understand that. And so for this, someone is asking, what does this statement here, num plus equals to 1? I think this shows that you've not been in class in our previous classes, because we've talked about this before. We talked about it I think in the first or second class, where I talked about arithmetic operation. I talked about the increment and decrement operator, and this is an increment operator. So it's just the same thing as this. When I come here and I say num is equals to num plus 1, and it's the same thing. All right, it's just being contracted to make the code look shorter and easier to read. All right, so that is basically what this thing does. So that's it for the break statement. I think that's very straightforward. The break statement is usually, it goes hand in hand with an if statement. All right, so for you to break it, there needs to be a condition, but technically you can actually use it like without if statement. For example, if I say while true, print this loop only runs once, and I say break. This is supposed to be an infinite loop, right? Right? This while true is supposed to be an infinite loop, but because the loop meets a break statement, it's going to stop, right? So that's why you usually use a conditional statement together with your break statement, because you just don't want to break your loop randomly. You want to break it for a particular purpose. All right. So just know basically what this break statement does, how we can apply break statement to our loop. So let's look at the next loop control statement. It is called continue. So continue is another loop control statement that we use in controlling the execution or the flow of our loop statement. All right. So what does continue does? Continue basically skips the rest of the current loop iteration and goes to the next iteration. All right, so continue basically skips the rest of the loop iteration, skip the rest of the current, this is very important, current loop iteration, and goes to the next one. Let me just move this. All right, so if we have something like this, let me bring back this example here. If we have something like this, or let me start with the first one. If we have something like this now, I want to use continue. So what continue does is that it doesn't stop the loop entirely. Continue, unlike break statement that will stop the loop when that condition is met, but rather it will skip that current loop. The current loop in this case is when I is equals to 6. All right. So I'll just print this out. I'll just say skipping 6 or skipping number 6. All right. So I'm going to run this. So once I run this, you see what happens here. 1 is printed, 2 is printed, 3 is printed, 4 is printed, 5 is printed. But when it gets to 6, it didn't print 6, right? Because this condition was true or is true. So hence, this continue statement is going to be executed. So as long as its condition is met, we're going to have this code print out, and then this continue statement is going to ensure that we skip that current loop, right, and then go to the next one. So in this case, we're not going to print this, it's just going to skip it. So let me remove this print statement here and just do continue. You see that we have 1, 2, 3, 4, 5. There's no 6. Then it jumps 6 and go to 7, 8, 9. So the same thing here. We have let's change this to 5. You see that we have 1, 2, 3, 4. It skipped 5, and then we have 6, 7, 8, 9. So this is just the idea behind if I make it 4, the same thing happens. So this is just the idea behind using the continue statement. It skips the current loop iteration and moves on to the next one. Right. So that I think that should be very clear. Break statement stops the loop and doesn't continue with the rest of the iteration. Why the while the continue statement, it skips that current iteration. It doesn't stop the loop entirely. It just keeps that current iteration and move on to the next iteration. All right. So that is basically how we can use continue and break. So let's give another example of continue. So we can come here and pick up this other example, which is this. I'm going to come here and say, for naming names, if name is equal to Yusuf, print Yusuf has been found, and then continue. All right. So I'm going to just do this, and you see that we have Job, Cletus, Yusuf has been found, right? Silver and treasure and silver. So that's basically what, if I remove this print statement, we're going to have this. So this commenting I usually do, like you might be wondering, how am I just commenting it like that? There's a shortcut for that. If you just press Control and /, it's going to automatically comment out your code. So let me type it out here. Control plus /. So the same way you do Control V, Control C, Control this, Control that, you can just say Control / to comment out that code. So if I come here and just Control / to comment it out. So that's how I've been doing it all this while, in case you are wondering, right? So if I do this, it's going to skip this particular condition that is met here, you sweep and continue with the rest of the execution. All right. So that's basically what continue statement does. I hope you are still following. Let me know in the chat. Are we still following, and do we understand what I've explained so far? All right. All right. All right. That's great. So, all right. So let's continue. So we're going to look at the last loop control statement, which is else statement. So we're going to look at else statement. So the else statement is pretty straightforward. So the else statement, it's what it does is that it executes a block in when we execute a block of code. Um, what the else statement does is that once the loop doesn't have a break statement, the else statement will be executed. All right, that's simply what it does. As long as your loop statement doesn't have a break statement, the else statement will be executed. The thing is that I really, to be honest, I really don't know. We don't have much use case of this else statement in Python, so it's not something you really use like that, but still good to know, right? So that's what the else statement does. If, as you can see, the else block after a while of for loop only executes if the loop completes normally without encountering a break statement. So that's just the else statement function. Yeah. Let's come here and do this. Let's just introduce this. So we have this for name in names. If this is equal to this, continue print name. So I can now come here and say else print else statement executed so successfully. All right. So you can see now that we're going to have the else statement execute and being executed, right? Because there's no break statement here. If I come here and I introduce a break statement, we're going to see that it's going to stop entirely and we're not going to have the else statement. So the else statement, like as long as the loop runs successfully. So the else statement is a way to check if your loop completes or is completed, right? The execution is completed. So you just there to kind of check to be sure that the loop that you've created runs successfully. It is completed till the end of the loop. So if it does not get to the end of the loop, it's not going to print or the else statement will not be executed. So if you want to be sure that your loop is executed successfully, you can just add an else statement to tell you if the loop is completely or has been completely executed. All right. So whenever you have a break statement, as you know, it breaks the loop at a certain point, making your loop not to execute completely. So hence the else statement will not be executed. All right. So that is what the else statement here does. Once says successfully. Okay. Yeah. Thank you. Is that can be added to any it can be added to your while loop, can be added to your for loop, but just understand that it executes only when there is no break statement. It executes only when your loop completely executes. All right, so that is what the else statement does. So I feel with this you should now understand how to use this loop control statement. You know how to use the break statement, you should know how to use the continue statement, you should also know how to use the else statement as well. So but the ones you'll be using most frequently are the break and continue, right? So depending on the logic that you're trying to write, you might be needing to use this loop control statement, right? So that's basically it about loops, right? So let me just go and just refresh us on loops and iteration generally. So loops and iteration, they are a fundamental construct that allows us to execute a code of block repeatedly. So I told us that we have for loop and we have while loop. So, a limited sequence, all right, a finite sequence, while loop is usually over an undefined number. So you don't really have a defined sequence, but you just want to do something until a condition is met. All right. So that is basically it for that. And we also have ways to control our loops, right, using the break, continue, and else. So that's it. That's it for loops and iteration. I expect you to go back yourself and practice more on this. Just check out more examples and see how you can use this concept that you just learned. So today we're going to be moving on to the next thing, which is functions. So we're going to look at functions. We're going to look at objects and objects in Python. All right. So these are the two things we're going to look at today. So let's look at what functions are. So functions is a very big deal, right? Function is a big deal, and for the fact that we've gotten to telling me that we've gotten to a very an advanced stage in Python. So this is a general concept in programming. Functions, regardless of the programming language, function is something that you need to know as a programmer. All right. So what exactly are functions? So for some of us, this is an entirely new concept. We know what function is, like aside programming, like you know what function. If you say what's the function of this thing, you can tell us it's basically like what's the utility, like what is this thing used for? That's what function is. All right. In our normal vocabulary. So now just separate yourself from that meaning. All right. That is it does not entirely mean the same thing. What function means in programming, or specifically Python, what it means are like we having reusable or packaged codes that can be used multiple times. So it's like functions is like packaging a code into something and then using it multiple times. That's what functions are in Python. So functions and variable, they are almost similar. They are in its definition or in its use, they are quite similar, right? So since you understand what variables are, I'm going to use that to explain what functions are. Remember I told you that variables are like a bucket that you put a data inside and that you can carry it along with you, and then you can bring it out whenever you want. So you can pass the data to a variable and then take the variables along with you during across your notebook and then use it repeatedly. So that's what variables are. The same thing applies to function. Variable, they just store a value or values, right? They store data basically. That's what variable does. But function stores something that can be executed. All right, it stores things, a collection of code, all right, a blocks of code that can perform a particular action or a particular task. So it is more complicated than variable. Variable, it doesn't perform anything. You cannot use variable to when you assign a value to a variable. That's it. You can only you can only like bring out the variable and then print it out and see what the content of that variable is. But for function, when you define a function, you can bring that back that function and use it to perform a particular task repeatedly as many times as you want in Python. So remember, we've looked at several functions before now. We've looked at can someone just like give us 2 examples of functions that we've looked at? I know we've looked at a lot, but just let's say 2 examples of functions that we've looked at in the past in our classes, in the past classes we've had. Exactly. So we've looked at a lot of functions in our previous classes. We've looked at print function, we've looked at type function, we've looked at range function, we've looked at int function, we've looked at float, and a lot of them. So all those things, they are actually functions. All right, and I'm going to explain exactly the types of function we have, and under which category those specific type of function fall into. So now, as I've explained, Python has defined blocks of reusable code. So this is the keyword here. They are reusable code. So once you write a code and you want to reuse that particular code somewhere else, instead of you to rewrite that code again, you can easily just package it into a function so you can call it when you need it. That's just what functions are. So the same way variable is like assigning a value to assigning a value to a particular variable name. Instead of typing out that value each time, let's say the value in that case is a list. Instead of typing that list each time that you want to use it, you can easily just pass that list to a variable and then call the variable whenever you want to use it in your code. Same thing applies to function. Function is like a block of code that you want to reuse again. So you can package those code and assign it on. So easily you can just call that function later on, and then it will do the same thing that it did when you defined it. All right. So that's what function is. I believe as we are moving, we're going to expound and you're going to understand and appreciate it better. So functions are fundamental to Python programming, enabling modular, organized, and efficient code development. See, most codes are actually written as functions. Like a lot of functions are defined, and then those functions are used to do a specific task. So if you like look at a particular script, let's say a Python script, most likely what you see there are functions. Right, that is mostly what you see there. So these functions will now have all these things that we've learned packaged inside of it. We now have loops, we now have if statement, an else statement, variables, and everything that we've learned so far. All right, so it's just like packaging all these things we've learned into something. So by defining functions, programmers can break down complex processes into manageable pieces, enhance code readability, and avoid repetition. All right, so we're going to look at how we can define function. So, but before we go into that, let's look at the different parts of a function. So we have different parts of a function. We have a function name. We have parameters or arguments. We have function body, and we have return statement. So these are the things that you need to know about function. We have four different parts of a function. Let me go again. We have the function name. We have parameters or arguments, we have the function body, and we have return statement. But before we move on into this, let me just tell you quickly that we have two different kinds of function. We have built-in functions, and these functions that we'll be looking at since the print function, the type function, the length, all of these functions that we looked at, they are under what we call built-in functions. So these are functions that have been defined by Python. So they came with Python when you install them. So you don't need to define it. You just call it and it performs a particular action, right? So these are called built-in functions. So now the next kind of function we have here is user-defined function. So these functions is the one that we define by ourselves. All right. So we can use built-in function, and we can also use user-defined functions. All right. User-defined function. All right. And then we also have the last one here called anonymous function. So yeah, the attendance, you can just, I don't need to be telling you every time. Once it is 8, just sign your attendance. It's always going to be open 1 hour into the class and to last for 30 minutes. All right, so let's move on. We have the last one here called anonymous function, or it's called lambda function. It's like a short way of writing functions. So just look at it as ternary operations, like the conditional statement that we looked at, and we have what we call the ternary operation or conditional expressions, right? So this is just like a way of, this is similar to ternary operator where you can just have your if else statement in one line. So this lambda function that we have here is the same thing as the ternary operator, right? So where is that again? Okay, yeah. This last one that we have here is a way of writing our functions concisely, without having to write it in the regular way we would do. So let's quickly look at how we can write our own function, dwell on built-in functions. Rather, we're going to look at user-defined functions. So I'm going to teach us how we can write our own functions. So let's move on. So for that, we're going to be looking at a different part of a function. So we have the function name, we have parameters, we have function body, we have return statement. So the function name is the identifier for the function. So it's just the same thing as a variable name. When you assign a value to a variable, that name of the variable is what you're going to be using when you want to call up the variable again. So a function also have a function name. You can give it whatever name you want to give it, but just make sure that the name describes what you are trying to perform or describe the action or the task of that particular function. So this is the identifier for the function, which is used to call it later in the code, right? As I said, it should be descriptive of what the function does, and it should follow naming conventions in Python and that. So the next part we have here are the parameters. So this will make more sense when we start looking at how it is written, how we can write functions in code. But the next thing we have are parameters or arguments. So this is actually optional. Functions might not have parameters or arguments. They might also have parameters or arguments. So depending on what you want to do. So this will make more sense as we proceed. All right. So what exactly are parameters? These parameters are input values that you pass into the function. All right. So let me even just be demonstrating it as we are explaining, so you don't get lost. So we have functions. All right. Defining functions in Python. So to start or to define a function, when we want to write a function, we actually use the word define. We define a function. That's the way we say it in Python or in programming. We define a function. So the way we define a function is by using a keyword called def. So now you see that we've introduced a lot of keywords, like in our if statement, we introduced if. In our for loop, we use for and while. Now in functions, we are introducing def. So to define a function in Python, we have to start by writing def. So once we write def, Python will automatically know that, oh, this person wants to define a function. So everything is going to align in that regard. All right. So once we write def, what follows is actually the function name. So I will basically give you the structure of the function. So the function name follows. All right. So after the function name, you don't leave any space. Immediately after the function name, you open and close a bracket. Do you understand? You open and close a bracket, and then your colon, and then to the next line. So the next line is going to be the function body. So this function body will contain all the code that you want to write and everything that you want the function to do. So, and the last part usually is a function can have a return statement or not. So we're going to look at that. So you can have a return statement. All right. So this is basically how a function looks like in Python. So in this bracket here, we can actually have what we call parameters or arguments. So if we put anything here, let's just say parameters. If you put anything here, it will be called a parameter while defining the function. But it can be optional depending on the need of your function. Some function does not need a parameter, or they don't need arguments. So parameter and argument they're used interchangeably, right? So you can use either of them when referring to this particular concept. All right. So these are the different parts of a function. We have the definition keyword def, followed by the function name. Name can be anything you want to give it. Then followed by an opening and closing bracket. And inside the bracket, we can have a parameter which could be optional. All right. It is optional depending on the need of your function. depending on the need of your function. So we now have the function body, which will contain all the code that you're going to be writing in the function, right? All the thing you're going to be doing. So the function body can be actually very long, and it can also be actually very short. All right. So yeah, we're going to talk about the relevance of parameters in function definition. So the last thing here is a return statement. All right. So functions can have a return statement. We're going to explain also what a return statement is, but just know that functions can have a return statement. It is also what? It is also optional. It is also optional. So this is basically how a function is defined. All right. So we have the function name, we have the parameter here, we have the function body, and then we have the return statement, which is also optional, right? So let's quickly move on to the next thing here. So I've basically explained the different parts of the function here. So let me just quickly talk about this parameter argument, because they are actually the same thing technically, not technically, they're the same thing conceptually. But while using them technically, you should note that parameters are used while defining your function. All right. When you are defining your function, the value or the thing that you have in that bracket will be called parameter. But when you want to call your function and you want to assign a value, or you want to like give a value that has been defined during the function, you're going to call that value an argument. All right. So this is just a nuance, but it's not really a big deal. You can use them interchangeably. Nobody's going to penalize you for that. All right. So I just wanted to point that out. So now, how do we define a function? So this is a very simple function definition. All right. So we want to define a function named greet. We want to define a function named greet, and what this function does is that it greets a person, all right, by taking the name of the person as an argument or a parameter, and then returning this particular string, right, which is hello plus the name of the person and then with exclamation mark. So let's just quickly break that down. So in this example, greet is the name of the function as we've established. All right, greet here is the name of the function. Name is the parameter. Hello plus function body, and then return this is the return statement. All right, so this is basically what the function greet does. All right, so if you want to call the function, this is how we do it. We just call write out the function name, and then in and opening and closing a bracket, and inside the bracket we're going to include the argument. If it was indicated in the function definition, we're going to have to include an argument. So the argument is going to be the name of the person we want to greet. So in this case, we can just include Alice. All right, and so we're going to have this particular statement or the particular code executed for this person. So let's see how it works, right? Let's see how that works. So let's see how we can defining a function. So the first thing here is what? Using def, and then let's say we want to define greet. Let's say we want to create that would greet a person. It will take the name of a person as an input or an argument, and then greet that person, return a string. So let's say greet, open and closing brackets, and then we're going to have, let's first start with print. So we can actually just say print you can say this function greets a person. All right, so this is a very simple function. If I come here and I execute this, it's going to store the function in our memory. So when we come back and call the function greets, right, and we run it, you see that it prints out the function body, or it executes the function, basically printing out the function. We had it in the function definition. right? So you see in this case now, we didn't have any parameter and we didn't have any return statement. I just wanted to use this example to show you that parameters and return statements are optional when defining functions. We can actually define a function without having any parameter and without having any return statement. But as you move on and as your code gets complex, you most likely always use a parameter and you most likely always use a return statement. So now what does this return statement mean? Let me just explain that. So if a function doesn't have a return statement, the function itself is going to return none. All right, it's going to return none by default. Let me explain that to you. If I assign this function, I can actually assign this function to a variable. So I can come here and say my func. So I'm assigning this function to a variable. So when you what you're actually assigning to that function is the return statement. If I run this and I come here and I say my func, or say print you see that I'm going to get no. All right. Now let's just take it slowly because it's getting a little complex and I can understand. Let's go back now. I defined a function here and I deliberately omitted parameters and return statement because you can actually define a function without having these two things in as part of that function. So I now want to explain to you why or what a return statement does or what it means. So mostly when you are working in Python, you always assign your function the return statement of your function to a variable. So whenever you assign a function to a variable, what you are basically assigning to that function is the return statement. So if the function doesn't have a return statement, the value or the thing you are going to be passing to that variable is going to be none. All right. But if I come here and I have a return statement, instead of print, I have return this. Now, this is no longer going to be none. It's going to be this particular string that we are returning. I hope that is clear. So this is what return statement does in functions. So if you don't have a return statement and you want to pass that function to a variable, what you are going to be passing to that variable is going to be none. All right. But if you have a return statement, you can actually pass the return value to that variable, and you can now use the value or the variable to do stuff. So this is how different parts of Python is linked. This is how they are linked, right? So when you are working using functions, most likely you are passing the return statement of your functions to a variable, and you want to use that variable to perform another action and all of that. So once your code starts getting complex, you understand how and you appreciate how all these things are related, all right, and how they work together. So that is it for return statement. So in this case, let's just leave it at print. So this is how we write our return statement. Our return statement is a keyword, it's a statement, it's not a function, so you don't have bracket and opening and closing brackets. So you just write return space with the particular value you want to return, all right? So you can have anything here. You can have whatever value or whatever data type it is that you want to return, all right? So this is it for the first function without parameter. And I've explained return statement. So let's define another function with parameter. So defining a function with parameters or parameter, anyone. So now let's define a function with parameters. So I'll come here and say greet, all right? And then I want the function to take in as a value the name of the person. All right, so I want name, and I also want it to take in okay, let's just leave name for now, so just keep it simple. So but just know that you can take as many parameters as possible. All right, so what will inform your choice of including parameter is if you want to use those values in your function body. So in this case, I actually want to use this particular name in my function body. So once I define my function, I put this parameter, and I come to my function body, you have to use this parameter that you've indicated here. So I'll come here and say return, and then I will say f hello name, and then I'll just have it like this. All right. So now I've defined a function. Now this function actually takes in a parameter. So it has the entire complete part of a function. It has the function name, it has parameter, it has a return statement. So in this case, the return statement is both the return statement and the body of the function. So this is just the body of the function, all right? So in some cases, you might have a lot of stuff happening before the return statement. So I can have something like this, greeting, and then pass this particular stuff to it here. All right. So I'll now come here and say return greeting. So in this case, this greeting variable here is the function. All right. This is the function body, and then this is the return statement. So if I run this function, and I come here and I call the function. So whenever I want to use a function, we call it calling a function. Calling a function, right? So I want you to get used to these terminologies. So when you want to call a function, you call the function by the name that you defined it with. So I'll come here and say greet, and then I'm going to let me change this to greet2 because we already have one greet here already, one function, so to complete the namespace. All right, so I'll come here and say greet2. Now, let me just show you how important this parameter are. If I run this function without including an argument, this parameter that I indicated here, it is going to give me an error. All right. So if I run it, the reason why it's taking time because of it's not understanding what's happening, so it's going to throw an error. So it's going to throw an error for me here. Okay, first let me run this function first. So it's going to throw an error. So the error here is greet2, which is the function I've defined, is missing one required positional argument called what? Name. So another thing I need you to do as a Python programmer or as a data scientist is to be able to read error messages, because they will inform you of where the problem is happening. So it's not every time you see this red stuff and all this error that you now start panicking, like what's happening to my code. No, the error is actually pointing you at the solution. All right. In this case, it's even telling you the line of code where the error is happening. So it's pointing to greet2, which is here, and then it's saying the name of the error is type error. And what the error message is that greet2, which is the function you defined, is missing one required positional argument. So because when I define the function, I indicated a parameter here. That means when I want to call the function, I have to put a value for this particular parameter. So I have to come here and put a value, and the value should be what? A name of any person. So anything you want to put there. Let me just put Joseph. All right. If I run this, you see I'm going to get this particular output. Hello, Joseph. All right. So this is basically how you use functions. All right. This is how we use functions. So if I pass this function stuff to a variable, I'll just say var2. I can come here and print var2. You see that we have this hello Joseph. So there's a lot of flexibility with functions in Python, and it's a very, very interesting stuff. All right. So that's basically how we work with function. So even let's see. There's something I just want to show us now, that we can pass a function object to a variable. So if I come here and say var3 equals to greet2, can come here and say var3 and then I'm going to put name here. Let's just put Joy. You see hello Joy. So what I just did is now is I just transferred power from this particular function name to a new variable name. And then I can now use that variable can now act as a function, right? So this thing that we have here is an object, a function object. So as far as it doesn't have the open and closing bracket, it cannot be executed as a function. So if of the function, it's an object, and that object can be passed around. It can be assigned to a variable, and that variable will just inherit all the functionalities of that function, and it will behave like the function itself. All right. So this is how flexible functions are. Function is a very interesting concept in Python. It's like a fundamental aspect of programming. So you need to understand how to use it. All right. So this is how we can use parameters in function. So let's assume I want to include another thing here. I can say first name. I want to introduce two parameters. All right. I will say first name and last name. So now, when I define a function, I included two parameters. So when I want to call the function, I have to include two arguments in the function. So if I come here, let me just erase all this thing. I'll say greet 2. Put Joseph. Let's say Joseph. It's going to is okay. We have let me change this to greet 3 because it has the namespace already. If I run this and I run this, I'm going to get type error. Can someone tell me why we are getting an error now without even looking at the error message? Based on what I have explained, can someone tell me why I am getting an error? Exactly. So I think we are following at this point, and that is very good. So now, when we defined our function, we included what? Two parameters. And while we're calling the function, we just put in just one argument. So you can see how parameters and arguments now are used technically. So parameters are used when you are defining the function, and arguments are used while you are calling the function. All right, so that is how we use this naming convention in Python. All right, but sometimes they are mixed up, you use them interchangeably, and actually that's fine. But this is the correct way of using parameter and argument notations. All right, so in this case, we need to include another argument, which is going to be this last name. So I can put an here. All right, we're going to get any okay. So I need to change this function body here. See, because this name is this name variable is Yusuf here because it has been defined before. So I have to come here and put name, first name, and then I'm gonna put last name. All right. So I run this. So you can see now that we have what? Hello, Joseph and me. All right. So you can see how we can include more than one parameter in our function definition. All right. So this is what we call positional arguments. All right. So we have what we call keyword arguments. So these are actually advanced, more advanced stuff in function, but I don't want to overload us now. I need us to understand this these basics. All right, so this is how we use functions in Python. Okay, so that's it for defining a function and calling a function. So your function can have anything inside the body, right? We can let me just quickly even define a function. Let's see if we can define a function that looks or that searches a list for a particular name. All right, so let's just try doing this so you understand exactly how interesting functions are. So I'll come here and say def, and I will say the name of the function is search list. And then I'm going to be taking one argument or one parameter, which is going to be the name that you want to search for. So I'll say name, and then I'm going to come here. Oh, it's going to take two parameters. I'm going to take a list, right? And what a name. So this list is what you want to search, and this name is what you want to search for in the list. So I'm going to come here and say, and search through or loop to search for name in what list. So I'll come and use for loop that we've learned already, and I would say for let me see, for element, I'm trying to use something that will not conflict with name. For elements in lists, if name is equal to let's say if name is equal to elements, then print let's see, name has been in the list, right? So this is going to be what we are going to be doing, and can come here and I can just leave it here basically. All right, I can just break it, right? Since it has been found. So then run it. I hope everything runs well. So this is a function. So this is a function that we've defined now. We want to use it to search. We want to use it to search a list for a particular name. So if I come here and say search lists, so this takes two arguments. It takes a list argument. So I'll come here and just define the list argument. Let me bring up the one that we've defined already. So we already have names defined, all right? So I'll use names. I'll use names list, and then the particular name I want to search for is, let's say I want to search for Yusuf. All right. So I think there's something else I need to put here. I need to put an if statement. All right. I need to put an else statement rather, in case this doesn't come and say print have name not found in list. Okay, let me look at this, be sure that everything is good. So element this, if name is just element print blah 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 blah. All right. Okay, so let's try this first. So yeah, so you can see that it has run, but I just want to make the print statement and for understanding. So let's come here. Let's all right, so this is just a simple way of doing it. So with different names. So once it gets to a particular point where Yusuf is on the list, it's just like execute that particular code and then stop the execution, right? So, but it's actually a simple way of doing this, all right? So I just wanted to like use the for loop that we just learned and kind of put it together with function. But there's a simpler way of doing this, and we can just easily use membership operator or membership operation. We can say if name in lists prints name is found in lists. All right, and we can just come and say else statement, and we can just say print name is not in the list. All right, so we can have this, and then we can have this. So this is a simpler way of doing this search instead of using for loop. All right, so just use membership using membership operation. So you can see how you can see how you can actually follow my thought process here. I came up with a problem or something to do, and then I tried the for loop first, and I saw that it was not really efficient enough. So I thought of another thing that we could use in Python. So I was like, oh, we can just use the membership operation, which is going to be even much easier. So I can just come here and use this membership operation, which is name in list, and use the if statement to execute an action if that particular condition is true. All right, so this is how we actually program. This is how we approach programming generally. You use the things that you already know to solve a particular problem. So this is a function now. So I can actually now reuse this function as many times as I want. I've defined, I've written all the code that I want to write. I can now come anywhere and reuse it. So in this case, I can say, let me just use it to search for another name. I can say names, and I can search for, let's say, Ada. You can see now that it will say Ada is not in list. I can search for another person name. I can search for Precious. Precious is not in the list. So if you look at a name that is in the list, let's check which names are in the list. Okay, we have this. So if you come and put Job here, you see that it will tell me Job is found in the list. So this is how we use function. It actually makes it very efficient. It makes our code very, very efficient. Instead of writing the code multiple times or repeatedly, we can just package that particular function or the task that we want to perform into a function, and we can recall it as many times as possible across our notebook or whatever environment we are working on. Are we still following? And can we all still hear me clearly? And is the screen still visible? I need feedback at this point because I don't know how it is going on at your end. So I'm going to be closing the attendance at this point. If you have not signed for the past 30 minutes. Okay, so that is going to be it for functions. I don't want us to dwell much. Oh, we've actually dwelt much on it already, but I don't want us to stretch it longer than we have already. So, okay, so let me quickly introduce something or recall something that we learned prior to this class, which was docstring. Remember I told us about comments and docstring. So docstring is used in functions, all right? We actually use docstring in function to explain what the function is doing. So in this case, the docstring is going to be inside the function. We're going to have the 3 quotes, all right? And we're going to have the opening quotes and the 3 closing quotes. And in between the quote, we're going to have an explanation or a documentation of what the function does. That's what docstring means, documentation string. It documents what that particular function does. So if, let's say, you want to use a function and you don't know what the function the function do, you can easily just call the docstring and it will explain it to you. All right, I'm going to show you how to do that. But in this case, let's just say this function takes 2 arguments, lists, and name, and it searches if name is in lists. All right, so let's just leave this as the definition or the explanation of the function. So this is a doc string. So if you run this doc string is actually going to be stored, right? It's going to be stored as part of the function. So when I come here and let's say I want to understand what the function do, I can just call the function here, lists, all right? And I think it should be double underscore doc. Doc, closing brackets. Let me be sure that. Okay, so this is it doesn't have a closing and opening bracket. So this is how we can call this particular doc string for this function. So a programmer will always explain the function using a doc string, so that whenever someone else wants to use that function, they can easily just call that this doc attribute to give you the explanation. Yeah, so let me just use a print statement to display it very well. All right. So this is the doc string of our function. So we string using double underscore doc double underscore. All right. So this is an attribute. This is an attribute, and this is what we're going to learn after this function. We're going to learn methods and attributes. So this doc is an attribute that we can call to give us the doc or the documentation for that function, in case we want to understand what that function does. So we can apply this. There are some functions that have documentation. There are some that does not have documentation. Let's just try this on different functions that we already know. Let's try this on the type function. Remember the type function, right? You can come here and say double underscore doc. So this is the doc string for this particular type function. So this is basically, sometimes the documentation will not really be easy for you to understand. Sometimes it will be well detailed. Sometimes it will be just something that is brief and not really clear, right? So just use this particular attribute to understand what a function does by accessing its doc string. So that is how important doc string is in Python. All right. So remember, we discussed that in the early classes, and I told you that once we start treating function, I'm going to show you exactly where the doc string comes in. Right. So when you want to call it, make sure you don't put in the opening and closing bracket. This opening and closing bracket after a function name is telling Python to execute that function. All right. So if you put it, it's not going to give you what you want. You just have to remove it and then call this particular attribute on the object, on the function object itself. All right. So that's going to be it for that. For doc string and functions generally. So this function, it might be a lot taking because it's a very important concept in Python. This is just like functions. So just take your time and go over this video again. Try creating functions yourself. Try playing around with all of this, and you see that you'll begin to understand it even more better. All right. So there's really nothing there in functions, right? It's just a way to package your code and call it whenever you need it. All right. So just know that there are actually a lot more to talk about functions, but I want us to understand this first. Moving forward, we might be introducing some new things as we go on and build on what we've already learned. All right. So let's go straight to the next thing that we have today, which is going to be objects in Python. We're going to look at what objects are in Python. So now we've looked at a lot of stuff. We've looked at variables, data type. We've looked at if statements. We've looked at for loops. We've looked at functions. Now we are going to be looking at objects. So objects is a concept in Python that you need to understand. It's not necessarily something that you can implement. So we are going to try to understand exactly what objects are. Now you can see that the first few words or the first sentence here says that everything in Python is an object. Yeah, I'm going to repeat that. Everything in Python is an object. All right. So everything we've been looking at basically from the beginning of our classes, from the first class to now, everything that we've looked at in Python, everything is an object, right? So even values of primitive types, integers, string, floats are objects, lists are objects, tuples are objects, dictionaries are objects, everything. And there is something that's peculiar about objects, all right? Objects have attributes and methods that dot syntax. So now when I say everything in Python, just exclude keywords, like keywords that we've looked at, right? Keywords like if keyword, for keyword, def keyword, and all of those keywords that we've looked at, all right? So aside those keywords, every other thing is an object. And an objects behave in different ways depending on their types. All right. So we have here objects have attributes and methods that can be accessed using dot syntax. So let's pick one example of an object. Let's say an integer now. An integer value of 8 is an object. All right. So that particular object, it has attributes and methods. So attributes and methods are the things that can make your object in ways. All right. So I don't want to go into classes and object-oriented programming when I start to explain that every object is in a class, or every object belongs to a class, right? So that is a different thing entirely, and that is a more advanced concept in Python, right? But for now, just know that everything is an object, and objects behave in certain ways depending on their attributes and their methods. All right. So what exactly are these attributes and methods? So for example, now we want to define a new variable of integer type. So we want to define age and assign an integer to it. So this particular age now has taken in all the attributes and methods of an integer object. An integer itself is an object, all right? So all data types are objects, right? Functions are objects. So let's just leave it at that. Data types are object, functions as well are object, variables are object as well, depending on what data type or what value the variable was assigned, right? So let's just boil it down to these two so you understand it better. Data types, all data types are objects. All functions can be objects, as I explained, without the opening and closing brackets. And variables as well are objects, depending on the data type that is assigned to it. So for instance, now we have the age variable that was assigned this 8th integer. Now, age now has access to all the properties and methods defined for all int objects. All right, so let's look at what that means. So I can sense that this is getting a little advanced, but just stay with me here. This is basically what we've been building up to now. So it's nothing different from the previous ones that we've done. So just try to understand the basics, and you'll definitely follow along. So we have objects in Python. Let me try using a real life example to drive home this point. So let's use what we can see as an example. So we have things like, we have different objects in real life. We have cars, right? We have standing fan. We have our laptops. We have we have animals, we have doors. So anything you can think of, basically, they are all objects. Like I'm not talking about programming. I want to drive home this object point by using everything that we can interact with. They are objects, and these objects, they belong to a specific class. All right, I want to go into that. They belong to a specific class. For example, if you look at if you just go to the road, you most likely see a vehicle passing, and the vehicle might be like let's say a Toyota vehicle. All right, that Toyota vehicle it belongs to a class, and that class is what? Vehicles or car. So let's say we have a class called car or vehicles, and Toyota belongs to it. That Toyota is an object that belongs to a class called car. And that class particularly, the reason why we categorize all these different objects in a particular class is because they all behave in a certain way. You can't classify, let's say, a standing fan with a car. We can't put them in the same class because they don't behave, they don't have the same attributes, they don't have the same functions, or let's say they don't have the same methods. All right, so they belong in different classes. Standing fan belongs to let's say a class of fans. So we can have ceiling fan, we can have standing fan, we can have different kinds of fans, right? So they belong to a class called fan because they all behave in a certain way. So the criteria for grouping different objects in a class is based on their behaviors and their attributes. So if you look at a vehicle now, you know that a vehicle has most likely, right? We might have some exceptions. The vehicle has, let's use the standard vehicle. We have 4 wheels, right? It has a windscreen, all right? It has a steering. It has all these components of vehicles that we all know that makes up a vehicle, right? So if you know that the standing fan does not have the same attributes with this with the car object or with the Toyota object that we've looked at, right? So basically, what I'm trying to say here is that the same thing applies in Python. We have different objects in Python, but these objects belong to a specific class, and the way they behave is different from the way other objects that belong to a specific class behave. So an integer now is a class, right? We call it an integer class. So any value that is an integer, we get all the attributes of the class integer that will behave the same way as all the other objects in that class integer. So for example, we have something like this: int1, 6, int4, int3, 7. So what am I trying to show us here? I'm showing us different objects. Now, 6 is an object, 4 is an object, 7 is an object, right? But this object belongs to a class called integer, all right? So it behaves in a certain way. It has different attributes as we are going to have for, let's say, float 1, 6.1, float 2, 7.3, float 3, 6.3. All right, let me just give you other example. Let's say list 1. I'm going to have this. Let's say 1, 2, 3. List 2. We're going to have A, B, C. All right. So now, these examples I have here, they are different objects. So 7 is an object, 4 is an object, 6 is an object, 6.1 is an object, 7.3 is an object, 6.3 is an object. This list that we have here, 1 to 3 is an object. This list we have here again, A, B, C, is also an object. But what I'm trying to explain is that this object is not the same, does not behave the same way as this object. This object does not behave the same way as this object. They behave differently because they belong to different classes, and the class they belong to determine how they behave. So when we came and we're looking at attributes and methods, that is what basically distinguish different objects. So each object that belongs to a class have or different attributes from another object that belongs to a different class. So the attributes that a list we have will be different from the attribute that a float we have, will be different from the attribute that an integer we have. So this is a very important concept that you need to know. So how do we now know the attributes for these different objects? That's very that's an important question. So to get the attributes for each object, we use a function called dir. All right, dir. So once we use dir, we are going to, as usual, as all functions would have it, opening and closing brackets, it will take in an argument. The argument is an object. So let's take in a list object, which is list1, all right, and we run it. Okay, I've not run this cell yet. So and we run it. You see that we have of output. So all these things that we have here, let me print it out. So all these things, let me zoom out. So all these things that we have here, they are the attributes and methods of a list. So this is how we know the different attributes and methods of a list. So these are the things that determine how a list will behave. All right. If I do the same thing for, let's say, an integer, I didn't do for a string as well. Let me come and say string1. Let me say hello. String2 Python. I'm just using this for now. So I'll come here and say print dir. So keep this particular function in your mind, dir string1. So what I want to do here, I want to get all the attributes and methods for this object. If I run it, you're going to see we have quite some number of attributes and methods. All right. So when you look at this, you see that we have some stuff that are having double underscore at the beginning and double underscore at the end. That's not your business. So for now, just ignore all these ones that have double underscore. What we'll be focusing on are just the ones without double underscore at the beginning and at the end. All right. So these are the things that will enable you to modify how that object will behave. All right. So these are the different, so they are called methods, attributes and methods. Methods are functions, or methods are functions that are accessible by an object. I'm going to explain exactly what we mean by that. So, but this is how we can access the different functions and the different methods and object and attributes of an object. So there's something I need to tell you, which is important. Methods is the same thing as function. But the reason why we call it method is because it is attached to a particular object. So remember when let me just quickly give us an example. For example, we have string1 object. So this is a string which carries the value hello. All right. So if we want to access a method of this string, we can just use dir to get everything here, and we can check for any method here. So let's say we want to pick up this method is upper. So each of them have a particular action they are performing. All right. So all these things that we have here that are called methods, they're actually functions, right? But these functions are attached to a particular object. So the way we can call them is by using the dot notation. So when we call a particular object, we just we follow it by typing a dot. All right. That's how we can access it. After the dot, we are not going to write or follow it with the function the method that belongs to that particular object. So in this case, we have is upper. All right. So I'm going to say is upper. All right. And then followed by opening and closing bracket. So this is upper now is actually a function, but we call it a method because it is attached to an object. Methods and functions, they are the same thing. Functions usually stand alone. When you use the word function, it is standing alone. It is not attached to any particular object. But when we use the term method or notation method, it's basically because we are attaching that function to a particular object. So we are using that function, we are modifying the object with that function. So that is why I tell you that all objects behave in certain ways depending on the class they belong to. So this class called string have an attribute or a method called is upper, which can modify the string. So what this particular function or method does is that it converts the string to uppercase. Sorry, it doesn't convert it. It tells you if that string is in uppercase or not. So they usually return either true or false. So if the string is in uppercase, it will return true. If it is in lowercase, it will return false. So our particular method capitalize each. So I think it should be case code. Okay, that is lower.
I didn't understand.
So there are actually a lot of methods here. So you just have to get used to the most common one that you'll be using. Where is this particular method? This capitalize should be for the first word. Let's see. All right, let me check capitalize. Capitalize. So it capitalizes the first word. So I think I'm just missing it now. It's there somewhere. So what that particular one does is that convert all the string value to uppercase. All right. So that's basically how we use methods in Python. So we can modify the particular object using several methods. So in this case, we see that these are the different methods of a list. So we just have limited methods here. We have append, we have clear, we have copy, we have count, we have extend, we have index, we have insert, we have pop, we have remove, we have reverse, we have sort. So let's just see how we can use some of them. So just to show you how these things work. So let me come here. Then I think I have list one. So I'm going to say I want to add another value to this list. All right, I'll come and say append using the append method, and then the append method will take in visually a single integer. Let's say in this case I want to add 4. Then I'll run it and come here and print out my list. You see that it has added 4. All right, the reason why I added it again was because I executed it twice. If I do it multiple times, it keep adding 4 to my list. So this is the way we can actually modify an object using a method. So let's look at another method of the list. So we have count. So I think what count does is that it counts a particular item in that list. So I'll come and say count, and then let's see, takes in an argument. What is my list one? 2. So my list one has so it takes in an element that you want to count. So in this my list one, I have let me print it out here. I have this element in my list, and I want to count how many times 4 appears in my list. So I can just use this particular count method, and then it takes in the value that you want to count, and then you run it. So you can see that it counted 4, and then it returns 7. So we have 7 fours in my list. So that's what counts does. So you can actually play around with different methods here, all right, to see how they can modify your list, right? So you can sort your list, you can remove an item, you can reverse your list, you can insert something, you can extend it, you can. So I just play around with it. You have your Jupyter notebook and the environment all set up. So you shouldn't have a problem trying it out. So this one is for your string. So we have functions or methods that you can use for your string. So you can use any of them, all right? So you can, okay, I think this upper here is what I was looking for. So just hidden in plain sight. So you can see that we've used upper now, and it has converted everything to capital letter. So if, let's say, you have a variable that is a small letter, a string, you can convert it to a capital letter by using upper. You can convert it to a lower case using lower. You can do a lot of things. You can check if it is upper letters, if they are upper letters. Even if your string have values in it, you can check if it is a decimal, if it is digits, and a lot of other things, if it is numeric as well. So this is the beauty of attribute, right? And methods, right? So most of these things are methods, right? There are some that are just attributes. So for attributes, you would not be using the opening and closing bracket because it's just an attribute. So some of these things, they don't really have attributes. So the attributes are usually these ones with underscore here, but you don't really need it, right? For this particular for the course of this program, we are not going to be looking at all of this because it is irrelevant at this point. So these are the ones that you just need to pay attention to. So that is it for attributes and methods. So you can actually check it out for other data types you have, right? You can check it out for you can check out the attribute and method for other data types, for dictionary, for tuple, for sets, and I think that's basically it. So I think for function as well, let me see. I have my grade 2 function. So if I use this on the function, you see that I have a lot of stuff here. So this is an object. So when I call on the dir function on this my function object, it gives me a list of different attributes for that function. So the doc statement that we used the other time, or the doc attribute, this is it here. The underscore doc to get the documentation. So this doc now is referred to as an attribute. It's not a function, it's not a method, it's an attribute because it is a characteristic, it's something that is part of that object. So you're not trying to make the object perform a particular action or do a particular task or modify the object, which methods actually do, but you're just trying to extract an attribute or extract something that is part of that object, right, from it. So this is how you can interact with your different attributes and methods for different objects. So I think this is a lot to take in at this point for some of us. All right, we are actually taking a big step, and I believe you are going to get comfortable with this as we move on, and as we give out assignments for the week. I'm going to ensure that you practice all of this and you internalize it. So by next class, you should be comfortable with all of these things that we've explained. You should be able to write functions. You should be able to understand how to assess the different attributes and methods of a particular object. All right. So we are going to be stopping here for today. I think we've covered everything. So I'm just going to be going through the remainder of the materials. And if there's anything that we're leaving out, I'm just going to breeze straight. So let me just go back to what attributes and methods are. So think of attributes as characteristics or properties of an object. So they describe the object state or features. For example, if you have a car object, its attributes might be like things like color, make, model, and year. Why methods are like functions? Methods are functions, not like functions. They are functions that are associated with an object. They represent actions or behaviors that the object can perform. So for a car, example, a method of a car can be accelerate, brake, stop, close door, wind down, on AC. So everything you can perform in a car is actually a method because they are attributed to a car. You can apply that same function to a standing fan because a standing fan is in a different class and is an object of a different class. So that method is specific to that object. So if you come to a fan now, a fan will have different methods. It will have methods like on the fan, increase the speed, and maybe if your fan is has rechargeable lights on the. So this is the sense of what methods are. This is basically what methods mean. So they are functions that are associated or attached to a particular object. So that is going to be it for that. I'm trying to round off with this particular from next week, we are going to be going into something entirely different. All right. So I believe by now we've gotten to understand what functions are, what attributes are, what methods are. We can assess attributes and method, and a lot of other stuff that we've discussed. All right. So what do we have here again? So I have a couple of attributes and methods that I outlined here in the material. So for integer, we have this. For float, we have this. For string, we have this. For list, we have this. For tuple, we have this. For dictionary, we have this. For set, we have this. So these are the basic common attributes and methods that we have for your different objects in Python. All right. So with this, we're going to be calling it a day. We've actually looked at a lot today, but the most important thing that we looked at is function. Please, if you don't even go home with anything, just make sure you understand what functions are, how you can define function, and how you can like interact with function and use functions in your code. All right. So that's going to be it for today's class. So we've ended the first segment of this program, which is Python programming. So we basically covered the basics of Python that we will be using going forward. So, all right. So every other thing we're going to be doing going forward will be what we've learned so far. So ensure that before the next class, you brought yourself up to speed with the course materials and with the classes that we've had so far. All right. So I won't start explaining all these things again, and I won't entertain questions that refer to what we've already looked at. Right. Everything has been provided for us. Next week we're going to be moving into NumPy. We're going to be moving into data science and other stuff that we're going to be using for data analysis, which is not going to be Python basics again. All right, so that's going to be it for today's class. I'm going to be taking questions. We've overshot already, and I want us to be ending as soon as possible. So I'm going to be taking a few questions before I end the class. If you have a question, please just indicate, and I'm going to be taking. All right, so I see Vivian's hand up. So Vivian, please ask your question quickly.
All right. Good evening, sir. Thank you so much for today's class. My question is, as regarding this last one that we just the print dir string 1 that brought out those stuff. If you do string 2, are there still different stuffs to be brought out or the same thing?
What do you think? I explained that each object belongs to a particular class, and a class defines the methods and the behavior of an object. So if we have, let's say we have a class called car, and then we have several brands of car like Toyota, Mercedes, Ford, and the likes, right? are these are different objects, right? If I let's say call if I call if I try to list out the different functions of Toyota, and I list out the different functions of Ford, right? General features, right? And I list out the general features of let's say Mercedes. Generally, am I going to get the same functions, like the same functions from these different objects?
No.
I should basically. No, I should. Like aside the different
Brand name.
nuances and all of that. But I should have a general
Sure.
method that pertains to that particular class called car. So in this case, in Python, this is actually not a very solid example, but in Python we have different data types. We have integer data type, we have float data type. So an integer data type is a class that can have plenty objects. So an example of an object is a value, like an integer value, like 8. 8 is an integer value. 6 is an integer value. 4 is an integer value. But all these integer values, they belong to the same class. So regardless of the particular integer value you are calling that dir function on, it will also always give you the same list of methods and attributes because all of them are in the same class. The only time you get a different attribute or method is when you call an object that is not in the same integer class. Like if you call a float object, if you call the dir function on a float object, it's not going to give you the same list of methods and attributes that will give you when you call integer. So to your question, yes, you're going to get it if you call dir on string 2, if you call dir on string 3, if you call dir on string 4 and the rest, you're going to get exactly the same thing because this particular object is of string class, is an object under the class string. All right, and all of them have the same functionality, the same attribute. I don't
All
know
right,
if you
sir.
understand.
Yeah, understood. Then the last question is, you said methods and functions are the same thing, but methods are attached to. Can you explain that part? The
Yeah.
different, two different.
So let me just put it this way. All methods are functions, but not all functions are method. That's
Okay.
basically how I can explain it best. All methods are functions, but not all functions are method. So the reason why we call it method is use that function together with an object. Like we call it from an object. We don't use it as a standalone function. When the function is standing alone, like you are not attached, it is not attached to an object. It is called a
Mm.
function. All right. But when that function is now attached, is associated with an object, it's called a method. But technically, they do the same thing. Both of them are functions. It's just they're trying to give it another name so we can understand exactly how to. Naming convention is very essential so we can explain stuff and all of that, right? But technically, they still do the same thing. But we call it method when it is attached or associated with an object. The same way parameters and arguments mean the same thing, but parameters are used when we are defining our functions, while arguments are used when we are calling the function. So you can interchange or use these things interchangeably, and nothing will really happen, right? People will still understand what you're doing. Programmers will still understand what you're trying to say, but technically, there are differences when it comes to methods and functions. All right. I don't know. I hope that was clear enough.
All right, sir. Thank you so much.
Okay. So do you okay, let's just move on to the next person. Sunday Salahu. Please ask your question.
Okay, good evening, sir, and thank you so very much for today's class. My question, when we're talking about the parts of functions, you mentioned the function name, parameter or argument, then function body and return statement. Because I want to ask that, because you said the parameters and return statement are optional, my question is that does parameter, if stated, does he bring out a return statement, or I want to know if parameter actually affects or determines whether or not return statement will come. Then my second question is, I still need some form of clarity on the difference between parameter and arguments. I'm trying to find myself understanding that. Thank you, sir.
Okay. All right. So for the first question, you can there is no connection between parameters and return statements. You can have a functions that have parameters without return statements. You can also have a function that does not have parameters and that has a return statement, as well as you can also have a function that has both parameters and return statements. So it doesn't affect parameter having parameters doesn't affect whether you have a return statement or not. So they are independent of each other. All right. So the parameters, where the parameter is needed is in the body of your code. The reason why you have parameters on that particular value that you are going to be passing into the function. So it is usually in the body of the code that you make use of your parameter. All right. So for your second question, parameter and arguments, when you are defining your function and you put a name in that bracket or something that like you want somebody or you're going to be using when you call your function, that particular thing or that particular value that is written or typed in that bracket, inside the bracket at that point of definition is called the parameter. So a parameter is called a parameter when you are defining your function. But when you are calling your function, the thing inside that bracket is no longer called a parameter. It will be called an argument. So the difference between a parameter and an argument is based on the stage of using your function. So at the definition stage, it's called a parameter, while at the stage where you call your function or use your function, it's called an argument. So even if you don't really get it now, just don't worry so much about it. With time, it's going to like become clearer. That is one thing about programming. You might not necessarily get this concept immediately, but as long as you are trying to understand it, at a point it will become very clear to you once you like look at different materials and get it from different perspectives. I hope that helps.
Yes, sir. Thank you so much. I get it better now.
All right. So any other question? All right. AY, your hand is up. Please ask your question. AY, your hand is up. All right. Let me go for the last person. We are actually we spent so much time here already. We need to wrap it up. So Jimmy James, your hand is up. Can you ask a question? All right. Okay, since we don't have any other person, okay, Basil Miracle. Basil Miracle, please ask a
Good evening, sir.
Sir, can you hear me? Good evening.
yeah.
This is James. I just try to add up. Maybe I think I have a logic that will help us drive from that point. The parameters and argument, then functions and
Okay.
methods. Just like maybe using a logic as the surname, your father being the parameter, and then your name, which is your own name, not your father's name, then is the argument. Like when you attach it, uh, your father is the parameter, while your father, you become the argument. And just the same way to functions and method. Your father can stand on its own and be called his name, but you can be when you are there, they call your father, they call you by your father's name. So I just know where just to try to bring out if I try to help somebody to
All right.
understand it the way I understand it. Thank you.
Yeah, thank you very much. If possible, you can also put it in writing so that we can go through it in the group. Thank you. All right. AY, I unmuted you the other time. I don't know what happened. You can speak now. AY.
Okay, thank you very much. Good evening, sir.
Yeah, good
So,
evening.
question is still on this argument and parameter thing. I tried writing the code and I don't know if I missed a syntax. The printout is still giving me the parameter instead of the argument. I don't
The
know if
thing
I
is that I can't actually tell what the issue is unless I see what you are doing. So if possible, you can just share that on the Q&A group with a screenshot attached so we can figure it out. All right.
all right, sir.
Okay. Um. All right. Nigeria, your hand is up. Please ask a question quickly.
Hello, good evening, sir.
Yeah. Good evening.
Thank you. Today's class was so packed. So I'm trying to get a confirmation. So, like integers and strings are like type of classes, and each class is defined by attribute and method. And so the attribute and the method is what is unique that defines them. So it means I cannot carry the method of one class and try and apply to the other one.
Exactly. Exactly.
All right, all right. Thank you, sir.
All right, let me take one more person. I know this class was a bit above what we've been doing before, so I want to take as many questions as possible. Got Emmanuel Arinze. Is that your question?
Yeah, thank you very much, sir. I must commend you for to the program. I quite enjoyed
The line is breaking. I can't hear you.
it, even if it seems beyond
Your network is bad. I can't hear you.
what we've
All
been
right,
at so far. But I'll be saying, I just believe we will all cope through. Now, concerning the attribute
Emmanuel,
and
your network is a bit
method,
bad. I can barely follow what you're saying. So you know what? Just ask your question in the
problem
group because of,
my network.
so we'll
Hello,
just wrap it up here.
can you hear me now?
So let's just wrap it up here. I think we spent a lot of time, enough time here already. So if you have any other question, you can just ask on the group. And please, as we usually do, we learned a lot today. I'm very sure that everybody picked one or two things from this class. So whatever it is that you've learned, just write it out or type it out on the group. It helps you a lot. It helps you personally to reflect on what we've done so far and to just bring them back to memory. And it will help you retain those information even much better. So do that and enjoy the rest of your day. So see you next week, Saturday. All right. So we're going to be starting our class next week, Saturday, by 4 p.m. Right. But if there's any change to that, I'm going to let you know. So the assignment for this week is going to be made available on the platform by tomorrow, and the recording will also be made available as well. So thank you for your time and do enjoy your night and goodbye.